All right, so the last topic we have to talk about in this chapter is symmetry. Your goal for today, I can identify and describe symmetry in geometric figures. So symmetry is a concept that I remember learning in grade school. And I was in grade school, just a few years ago. But I remember learning it. We used to have these pieces of plastic that had mirrors on them, and we would put it on top of a piece of paper. And if you could see the other half of it reflected, then it was symmetric there. We don't need to do that now. We're older than that. We can look at it and tell if they're symmetric. So this warm up here says identify each transformation. So I want to know, is it a reflection, a rotation, a translation, dilation, or neither of these, or none of these, I should say. All right, so if you look at the first one here, it's turned. If it's turned, it's a rotation. Okay. Next one, if you look right here, there is a line I can draw right down the middle, and then it's reflected over that line. So this is a reflection. If you ever think it's a reflection and a translation, both of those combined, that means it's a rotation. Okay, so let's talk about two different types of symmetry. We have line symmetry and rotational symmetry. A figure has symmetry if it can be reflected across a line so that the image coincides with the pre-image. All right, so it can be reflected over this line so that this image, wow, that was bad tracing, coincides with this image here. Once again, terrible tracing. The line of symmetry divides the figure into two congruent halves. So the line of symmetry is also called the axis of symmetry. When we're working with parabolas in the next chapter, the line going right down the middle of it, that's called the axis of symmetry. But if you look at it, it's a line of symmetry. We're also going to talk about rotational symmetry. A figure has rotational symmetry if it can be rotated about a point by an angle greater than 0 degrees but less than 360 so that the image coincides with the pre-image. So this is going to be the hardest thing for me to show you, rotational symmetry that is, without being in class with you, because I do so many examples like in front of people with it. So I will start, hopefully I'll be able to show you in a Zoom lesson what I mean by rotational symmetry if you don't get it from these notes. All right. This is tell whether the figure has line symmetry. If so, draw all the lines of symmetry and state how many there are. So we're going to start just with line symmetry. So number one, are there any lines of symmetry? If you think so, pause the video, go ahead and start drawing them. Okay, so I'm going to tell you how many there are. 1, 2, 3, 4, 5, 6, 7, 8. 8. What do you think I was helping myself, or not helping myself, what do you think I was doing to help myself get that answer? Notice that there's these points on them and there's 8 of them. To me, that's a dead giveaway that there's 8 lines of symmetry. If you only drew 4, I know which ones you missed. Well, that's not going to help. So here's one. I'm not going to use the straight feature because it's going to take me forever to get them perfect. Here's one going through the corners, 2 going through the corners, 3 going through the corners, 4 going through the corners. Now, some people will be like, there's 4. See, there's 4. You said 8. But you forgot to go. I'm going to change colors here so you can see them. You forgot to go through here into here. So there's one going through those corners. That's one more. So that's 5, 6, 7, 8. 8 lines of symmetry. All right, looking at this next one here. Draw any lines of symmetry. There aren't any. There's no way I can cut that where it would fold on top of itself. All right, see if you can think about how many this one would have before you even start. Notice this figure right here repeats 4 times. So there are 4 lines of symmetry. People want there to be more than there are. So there's these 1, 2, which usually people find. But then notice if you go this way, and like if you look at it as an X instead of like a T, there's lines of symmetry there too. Okay? 4 total. All right, how many lines of symmetry are there here? 1. Okay. If you notice, it has this shape right here, this shape, and that repeats itself. How many lines of symmetry does this have? 2. 1, 2. I look at it as, oh, it has this shape once, and then it has this shape again twice. So that tells me in my brain that there's 2. I just have to find them. All right, this one right here. This one's arguable, I think. Like, I want to say that this is a line of symmetry right here, right? Can I hold it long enough that it'll go straight? No. I want to say that that's a line of symmetry. But if you look at the stars, do you see how these stars are not mismatched? And like, there's a star right here, but there's not a star exactly right here. So this one I hate, let's be honest. I think I've taught it as 1 always, but the more I look at it, I'm like, meh, 0. But we're going to say 1 pretending the stars aren't there. 0 if you look at the stars. Okay. Next, let's talk about rotational symmetry. The angle of rotational symmetry is the smallest angle through which a figure can be rotated to coincide with itself. The number of times the figure coincides with itself as it rotates through 360 degrees is called the order of the rotational symmetry. So I actually get the order first. So I say if I start turning this, how many times is it going to land on itself? So if I start turning this square, unfortunately on the iPad, I don't think I have the ability to rotate this. Let's see. No, I can just make it bigger or smaller. So if I rotate this, right, and this is the top, okay, and I'll put a little tick mark right here. I can rotate it to if I rotate it counterclockwise, the tick mark would be here. So that's 1, here 2, 3, and then back on itself 4. So it would look like itself 4 times. So that's the order. The order is 4. Now to get to the angle of rotation, the rotational symmetry, all you have to do is 360 degrees divided by the order. So 360 divided by 4, that means the angle of rotational symmetry is 90. Okay, so let's look at these and see if they have any rotational symmetry. So can I rotate this figure and it'll look exactly the same at any point? No. Okay, the next one, if I rotate this figure, will it ever look the same again? So this is I think the most confusing one. So I always say there's these straight lines right here, which I see, but then it goes, there's a curve up top and then it dips down. So if I flip my paper, there's got to be a curve up top and then it dips down. And at first I want to say that there's rotational symmetry. And if you turn it, you'll see that there is rotational symmetry. It will land on top of itself if you turn it. So yes, there's rotational symmetry. It'll look like itself just twice. 360 divided by 2 is 180. So the order is 2 and the angle is 180. If I turn this, how many times will it look like itself? 4 times. The order is 4. 360 divided by 4. So the angle is 90 degrees. If I rotate this, how many times will it look like itself? 3 times. 360 divided by 3, 120 degrees. If I rotate this, how many times will it look like itself? Twice. 360 divided by 2, 180 degrees. If I rotate this, how many times will it look like itself? None. There's no rotational symmetry there. Okay. So that's it for symmetry. I think that if people have a problem with anything, it's going to be forgetting to see how many lines there are, or with rotational. So if you have questions, please make sure you ask in class when we're going over it on the formative review. Go ahead and post-rate yourself on how you feel about symmetry. All right, now you can go